So let's talk similar figures here for a sec. One way I like to think about it is you ever take a picture and you make it bigger or smaller, but you don't distort any of the faces or bodies in there. Those are similar figures. They are still the same shape, they're just a different size. Now I'm going to talk about it in the context of triangles. So let's say I've got that guy, and let's say I've got this guy here. Okay, well, let's say these are right triangles. They don't have to be, but I drew them as such, so I'll mark them that way. What we're going to have with similar figures are these angles, the corresponding angles, will be congruent. And remember, in math land, those guys mean congruent when you have the congruent tick marks there. So similar figures are the same shape, the corresponding angles are congruent, but they could be different sizes. Okay, so you could have the same size and same shape. They could be congruent shapes, congruent polygons, and they would still be similar because they fit all the characteristics of similar figures. But generally speaking, when we're talking about similar figures, we are usually talking about something that is bigger or smaller than the original. So if this is the original and this is the next one, this is actually called a dilation. It's getting bigger. And if we're saying this is the original and this is the new one, that is called a reduction. It is getting smaller. So there's some math terms. Now let's apply some of this information about similar figures. So it's time to dive into some similar figures, ladies and gentlemen. Whew! This is going to be so important in this class. Alright, so we got Lil Yachty. He just bought himself a pontoon boat to rehab, and as you know, he's adding that third tune in the middle for a little extra stability, a little bit more capacity. Alright, and that thing is going to be called Lil Yachty. Huh. Got to name a boat after yourself, I guess. He needs to calculate the square footage of carpet to order. Or maybe he's going to get that nice seagrass stuff. It's not like carpet. It's pretty great. However, he only has blank blueprints. Now, he measured and wrote it down in the diagram above. The scale factor of the lengths of the sides of the blueprint to the actual boat is 1 to 48. How many square feet of carpet should Lil Yachty order? Okay, I'm going to move these directions up here so we can get out of the way and have a little bit of space to work. Obviously, these are pretty stripped down blueprints, but the idea is going to be the same here. Okay, so we are 1 to 48. 1 inch, you can think about this in a few different ways. 1 inch is to 48 as, let's go with the 2-inch side. 2 is to what? Well, if I were to cross multiply that, 1 times x, so 1x equals 2 times 48 is 96 inches. In other words, about 8 feet. Well, exactly 8 feet, excuse me. So 8 feet. That's what that actual dimension is. Whew, wonderful. And if I were to do the same with the other side, 1 is to 48 as 6 is to what? If I were to cross multiply that, I'm going to have x equals, well, 6 times 48 is 288. So 288 inches or 24 feet. Awesome. Remember that one little tick mark means a foot. Okay, so I have an 8 by 24 foot pontoon boat. Pretty standard, a little longer than some, but solid size nonetheless. Especially if you have that third tune, you're going to be cruising. Okay, so not too bad. We scaled that up. We went by whatever the scale factor was. However, in a construction class, it's going to be worded a little bit differently. You know what they're going to do when they give you a scale is going to be, well, 48 inches, that's 4 feet. So 1 inch is 4 feet, or in other words, a quarter of an inch is equal to 1 foot. That is how they are going to word it on those blueprints, so you do need to be aware of that. It's the same type of deal, though, guys. It's a scale factor. Okay, it's similar figures. A blueprint is similar to the actual thing. It's just when you build the actual thing, it's enlarged. It's dilated. Okay, dilated means getting bigger, enlarging. A reduction means that you're getting smaller. Those are some good math vocab words. America. So I'm willing to bet many of you did not know, but Drake himself is an avid gardener. He loves the garden. Now, he currently only has a 6 by 8 foot garden, 48 square feet. Not a whole lot to work with. And he wants to double those dimensions. You see, he's trying to get his foot in the door at the local farmer's market, right? He's kind of starting at the bottom at this point. How many square feet will that new garden be? Will it be enough to get him here? After starting at the bottom, will he be able to get here? Whatever that means. Well, how many square feet? Let's see here. Well, if I'm doubling it, I'd assume if I'm just doubling the dimensions, 48 square feet, I would double my area, and that would give me 96 feet squared, and I'd be done, right? Ooh, maybe not. Maybe not so fast. Let's think about that again before we jump to conclusions here. Okay, if I double my dimensions, I'm going to take that guy, I'm going to extend it 6 feet. All right, this is 8 feet. Oop. So I extended that. Now, this guy's going to get extended out 8 feet. Oh my goodness. So if I really connect this all, holy cow, I'm actually getting to be 4 times larger. All right? Because it's going to be 12 feet. All right, this guy's going to be 12 feet. And this guy's going to be 16 feet. 12 times 16 feet is going to give me 192 feet squared. Really, he's quadrupling the area when he doubles his dimensions. That is important, people. Okay? He's actually quadrupling the area when he doubles the dimensions. Area is units squared. Doubling squared, 2 squared is 4, 4 times. If I tripled the dimensions, this is fun. Well, tripling 6 is going to be 18. Tripling 8 is going to be 24. Well, if I triple those dimensions, let's see here, 18 times 24. Let me take out my handy-dandy calculator because those numbers are all big and stuff. That's going to be 432. 432 feet squared. Well, how much bigger than the original is that? If I take that 432 and I divide it by the original, which is 48, that is a 9 times bigger. When I tripled it, it was 9 times bigger. 3 squared, 9. Coincidence? I think not. If I quadrupled it, 16 times. If I multiply the dimensions by 5 squared is 25 times bigger. That's how area works. That is cool. Now that Drake has 4 times the garden space, he's no longer at the bottom. He is here at the farmer's market.